Mō rina koutou katoa nau mai, hara mai ki Piki Mai, ki tēnei whakāturanga. Ka nui te mihi rangatira ki a koutou, mō koutou mahi, mō koutou tautoko o te kaupapa i mo i a tātou. Nō reira, me tīmatarita i te karakia, kia ora tātou. Mīnoi tātou. Tukuru te wairua ki rere ki ngā taumata whai a te tika ngā rātou mā, hei ārahi i a mātou mahi. Kia pupuri ngā whakaro i whakamana i ngā tangata, kia mau ki ita tūturu whakamaua kia tīnā, haumi e, hui e, tāe e, ki e, nō reira, piki mai, kaki mai, nau mai.
Tēnā koutou katoa. Ko Justin O'Sullivan toku ingoa, ko o te manataki putahi ki Liggins o Waipapa Tōmataro. So I'm Justin O'Sullivan and I'm Director for the Liggins Institute. The Liggins Institute is a large research institute at the University of Auckland, and we're dedicated to improving lifelong health through excellent research into the determinants of what makes up a healthy life. Now, to do this, we have a really collaborative and transdisciplinary approach to research. That means we work across fields, across the university, and it gives us a way of viewing health problems from really different angles that enable us to explore the theories and the therapies and interventions that really have the biggest impact on your life and on people's lives. One of the projects we're running at the moment is one around newborn genomics, and that's one area where this is going to have a massive impact going forward, because we're trying to use genomes to understand why people have genetic disorders and to intervene very quickly. But there's much and many other projects that we're running at the same time that are doing very similar things. Now, our research is world class, and we're involved in many international collaborations. So we work with people from Harvard, from Baylor, College of Medicine, from A-Star Singapore, University of Southampton, Oxford University, Australia, all over the place. And these collaborations are key to what we do. And we've got a track record of translating our research into real world answers. And this is one of the most important things about the Liggins Institute, because our work changes practice, not just here in New Zealand, but all over the world. And the key sort of exemplars of that are the original people who did the studies here. So Mont Liggins, who the Institute is named after, who did a corticosteroid trial, which has changed premature birth and the way that works for people around the world. But the Sugar Babies trial, where basically we put a dextrose gel inside the mouths of children when they're born, and that stops neonatal hypoglycemia. Again, developed in the Liggins Institute, taken from there, changing world practice. Fantastic research. Now, we've got a state-of-the-art laboratory on site. Our lab contains everything from sequences through mass specs through to just running gels and doing simple PCRs and all those types of things. But it's a fantastic facility. But we've also got a family-friendly clinical research unit. And this unit is used for studies in babies, for studies in children and adolescents. And we have beds, we bring people in and they get standard clinical care. They go through all the tests, they can run on a DEXA. We have other machines as well that look after the kids and the people. Now, we're really privileged as well that we host university-wide services or platforms. So one of those is the Human Health Research Services platform, where we look at clinical trials and developing clinical trials, the things needed to support those. We have the Ngāpori Research Farm platform, which is a farm for large animal studies. Again, it's a really unique facility that's unique to New Zealand and to the University of Auckland and also to Liggins. And on top of that, we have an analytical platform which is run through our laboratories here by Eric and staff. It's a fantastic platform. So if you decide to come and be part of our family and join us, you'll contribute both to health knowledge and the delivery of healthcare that informs the best possible outcomes for the people of Aotearoa, New Zealand, and the wider world. And we've got a lot of alumni who are doing this in very high levels across the world. So at the Liggins Institute, we have a number of key research themes. The first of them is around the determinants of healthy life, where we're looking at the roles of our genes and the way that your DNA works, interacts with your environment, and helps us to understand how diseases develop. Healthy mothers, healthy babies. We do a lot of clinical trials where we're looking at pregnant women and their newborns, trying to determine best treatments and interventions to improve the child's growth and development. Nutrition for a lifelong health. Here we're interested in whether or not how nutrition affects life or long-term health, how it affects our responses to diseases in different ways, and how we can optimise that process. We're also interested in translating our research. So we call this the research to reality theme. And in research to reality, we're looking at moving research from the laboratory to the clinic. And as I mentioned before, the Sugar Babies trial and the genomics program are both very good examples of trying to do that. We also have people who are working in cancer research, clinical endocrinology, and looking really at the developmental origins of health and disease. So here at the Liggins, we can support you. We can give you scholarships and awards that are available for honours, masters and doctoral students. Now there may be philanthropic funding as well that's available if you don't meet the criteria for a University of Auckland scholarship. You will get access to support in seeking research funding from public good and commercial and even philanthropic avenues when that's appropriate. And the opportunity to disseminate your research widely, including to the public and through conferences, all types of things. We're really renowned for being a friendly environment. We've got monthly morning teas that are legendary. We cater them. Everybody enjoys themselves and has a great time. We have a great mix of local and international students, and our student body is really diverse and very welcoming. If you come to the Liggins, we will help you develop your skills. We'll help you develop them in the way that you want, towards the outcomes that you want, and we will support you in your goals and objectives. If you have any questions, please feel free to come and see us. I look forward to talking to you. Thank you.
The first 1,000 days of life refers to a child's life from the moment they are conceived until they reach 2 years of age. The environment an individual experiences in their first 1,000 days of life can have a significant effect on their health and well-being across the life course, and also that of the next generation. This is framed under what is commonly referred to as the developmental origins of health and disease hypothesis, or DOHAD, and is underpinned by a process preferentially termed developmental programming. Our research group examines the link between the early life environment and the health of offspring across the lifespan. A particular focus is on maternal nutrition and how changes in the nutritional environment of the mother can impact the risk of their offspring developing a range of metabolic and cardiovascular disorders in later life. To help us understand such developmental programming, we have developed a range of preclinical models that allow us to provide empirical data to support the DOHAD hypothesis and understand some of the mechanisms involved, including sex-specific effects. We look at a range of endpoint measures, including body composition, hormone systems, and gene expression profiles, and have access to state-of-the-art laboratory facilities. More recently, the role of the dad's health has gained increasing focus, with evidence that poor paternal health status can adversely affect the health of his offspring, and we will also be investigating this in ongoing work. We know from our extensive work to date that poor maternal nutrition leads to an increased risk for the development of a range of disorders in offspring, effects that are further amplified when they themselves consume a poor diet postnatally. We have therefore also been interested in potential strategies to reverse early life nutritional programming. Indeed, we were one of the first groups to show that developmental programming was reversible during using targeted interventions during early life. To date, we've developed a number of intervention strategies, including both nutritional and pharmacological approaches, but the next key step is translation to clinic. Following from our preclinical work in small animal models, we have also recently engaged in work in clinical cohorts to examine potential early pregnancy biomarkers that have utility in predicting later complications of pregnancy, including that of preterm birth. Another avenue that our group is interested in is that of adolescent health. With early life programming of later disease, the initial focus was on maternal health and more recently on the health of the father. However, there is increasing interest in the role of adolescents, the next generation of parents, as a critical window of opportunity to break the cycle of disease across generations. To do this, we are first doing studies to examine adolescent understanding of DOHAD concepts, and then engaging in approaches to improve health literacy of adolescents as future parents. This also highlights a further current issue that needs to be addressed and is part of our ongoing work. The DOHAD framework has been in existence for several decades now. However, it is clear from our work and that of others that public understanding of concepts related to DOHAD remains poor and needs to be better communicated. As part of this, we have been involved, together with a team of experts in Australia, to develop resources to aid in the promotion of maternal and paternal health in new and expecting parents. Thus, as you can see, we have a range of research activities underway. The common theme that pulls them all together is the importance of the early life environment, particularly early life nutrition, and how this can impact on health outcomes across the life course. A key component of this is around prevention of disease rather than treatment of disease once manifest, and looking at opportunities to break the cycle of disease across generations. This work spans from studies in small animal models through to clinical cohorts and working in schools in the wider community to improve communication and uptake around DOHAD concepts. We collaborate widely internationally and across New Zealand and have a number of exciting opportunities for postgraduate students. If our research interests you, why not get in touch to find out more?
Hi, my name's Ben. I'm a paediatric endocrinologist. That's a doctor who looks after children with growth, hormone problems and diabetes. Throughout my career, I've watched as more and more children with serious weight problems come through my clinic doors. Many have type 2 diabetes or high blood pressure, conditions that used to only be seen in adults. When I was at medical school, we weren't taught that these conditions even occurred in children. This is a global problem and a New Zealand problem, with a third of children about to enter New Zealand schools already overweight or obese. We all know that what we eat and the exercise we do are important for our weight, and many people recognise how this is affected by the environment we live in. These things need to be addressed, but there's another critical factor that we usually ignore, and that's the health of mothers, fathers and babies in early life. Events that happen to us in the first 1,000 days of our lives shape the way our bodies work. This influences our risk of weight problems and diseases like diabetes and heart disease as we grow up. So if you're a baby born very early, very late, very small or very large, to a mother carrying extra weight while she's pregnant, or to a mother with diabetes, your risk of weight problems and problems like diabetes and heart disease are higher in your lifetime. The situation I'm most interested in is when a mother is carrying more weight while she's pregnant. And that's because around 2/3 of women in New Zealand of fertile age are in the overweight or obese categories. And this means that 2/3 of children born in New Zealand are born at an increased risk of weight-related problems. The die is already loaded against them before they've even started. This can sound fatalistic, but it's not. It tells us that pregnancy is a special window of opportunity when a relatively brief intervention might have long-term benefits for the unborn child. Pregnancy is a time that women are especially interested in optimising their health because they want their child to have the best possible start to life. My research has been focused on trying to find a way to reduce the risk of weight-related problems for children born to a mother carrying more weight during pregnancy. We started with a study in rats, and we found that when obese rats take fish oil during pregnancy, it improves the metabolism of their offspring right through to adulthood. So since then we've conducted a randomised controlled clinical trial in women with elevated weight during pregnancy to see if fish oil could have similar benefits to their children. This treatment improved mother's metabolism by lowering the levels of circulating fats in her blood, and also improved metabolism in the 3-month-old babies. We're following up the children at 3 years of age right now to better understand the longer-term effects that treatment had on their bodies. But why wait until pregnancy to treat mothers? At Liggins, we've been a site for the NIPA study, an international study across New Zealand, England and Singapore. This randomised controlled trial was to find out if a preconceptional treatment containing a combination of supplements for women wanting to become pregnant who weren't pregnant yet could improve outcomes for the mothers and their babies, and the results are just starting to come in. And what about dad? We know less about the importance of father's health to the offspring, but we're now embarking on a study in rats to tease out the relative importance of obesity in mothers and fathers to the offspring. We're hoping to develop treatments that fathers could take before having a baby to help set up their child on a healthier path. If you're a student interested in the research we're doing and you think you might like to join our team, we'd love for you to get in touch. Thank you.
Kia ora koutou, my name's Lisa Dawes and I'm a senior lecturer here at the Liggins Institute and also an obstetrician and maternal fetal medicine specialist at Piki Mai, Auckland City Hospital. And my clinical and research passion is in preterm birth. So preterm birth is the birth of a baby prior to 37 weeks, and it can occur either after spontaneous onset of labour or pre-labour rupture of membranes, which accounts for about 2/3 of cases and is known as spontaneous preterm birth. The remaining third is known as provider-initiated preterm birth and occurs because early delivery is indicated for the health or well-being of both mother or baby. Preterm birth accounts for just under 8% of all births in Aotearoa, which is about 4,500 whānau who are affected. We know that preterm birth is important because not all babies are able to survive after being born early, particularly those at extremely early gestations. And those that do survive can have both short and long-term health implications, including things like cerebral palsy. And this has quite significant social, financial and wider implications to our community. We also know that preterm birth rates and outcomes after preterm birth are not the same for all, and there are differences according to region of residence but also ethnicity, with Māori, Pacifica and Indian whānau experiencing less advantage than our European and Asian whānau. So this is where Taonga Iho comes in, which is the knowledge translation for equity in preterm birth care in Aotearoa. And we've been working alongside the Karasika Collaborative, which is a stakeholder-initiated group of people committed to improving equity in preterm birth care in Aotearoa. And myself, alongside Professor Katie Groom, who also works here at the Liggins, and a group of researchers throughout Aotearoa, have been working across 4 different sub-studies with the overall aim of producing a national best practice guide for preterm birth care to improve consistency and outcomes in care, no matter who you are and where you live. And this has been funded by the Ministry of Health and HRC. So alongside developing the best practice guide, we've also been doing work looking at the enablers and barriers to care, developing implementation tools for when the guide is released, and also measures to evaluate the impact. And as we move forward to finishing this Taonga Iho best practice implementation best practice guide, we're looking to implement the project. So clinical practice guidelines can only be effective if they are implemented, and consistent and best outcomes for whānau will only be achieved if Taonga Iho is used in a consistent and equity-driven way. So we have just submitted funding applications for a nationally led and locally owned prospective, multi-site, multifaceted preterm birth best practice guide implementation program. And we are excited that 4 sites throughout Aotearoa have been invited and have agreed to participate. And this implementation program will include a targeted and supported program for organisational culture, education and audit and feedback. And there are multiple opportunities for both PhD students and master students to get involved in this mahi, and we'd be really excited to have you as part of the team. So you can contact either myself or Professor Katie Groom, and we'd be really happy to talk to you about any of these projects in more detail. Thank you.
In a world where the pace of life seems ever increasing, we often forget that we are aging, and the body is slowing down in all possible ways. Particularly as we age, our bodies face increased inflammation, contributing to chronic age-related diseases. But what if I tell you I can provide you ways to reduce the risk of these age-related changes? So, fear not, because nature in all its wisdom has bestowed upon us a unique mechanism. Now, you might ask me, what is this mechanism? Well, this is NRF2. It's a defense mechanism of our body that activates more than 200 antioxidant proteins responsible for detoxification and regulation of inflammation. Interestingly, it turns out that certain foods holds the key unlocking its potential. One such food is broccoli. Yes, you heard me right. Broccoli, within its vibrant green leaves, resides a magical compound called glucoraphanin that gets converted to sulforaphane in the human gut. It is this compound that is a potent inducer of NRF2 pathway, thereby reducing inflammation and restoring a healthy balance in our body. Although we know how sulforaphane activates the NRF2 pathway, what remains unknown is how consuming moderate amount of these vegetables might unlock a world full of benefits for vital organs such as the brain and the prostate gland. This is where my story comes in. And I hypothesize that it is via small practices produced by liver, known as extracellular vesicles or EVs for short. EVs are tiny messengers that can transport antioxidant proteins from NRF2 to different tissues throughout our bodies, which can potentially influence processes involved in age-related chronic long-term illnesses. To test my hypothesis, I will carry out a randomized, single-blind, 2-arm crossover study by examining the effects of a glucoraphanin-rich vegetable soup versus a vegetable soup lacking glucoraphanin on the composition of the extracellular vesicles in healthy older adults. Blood and urine samples from these participants will be used to isolate the EVs. Several molecular techniques will be used to confirm the presence of EVs, followed by comparing protein composition of EVs by methods such as ELISA in between the two arms. Therefore, by comparing these effects, we can uncover how the hidden secrets of these remarkable vegetables positively impact our bodies. The findings of my study may shed light on new ways to promote healthy aging, opening doorways for innovative therapies and preventive measures. So, if aging gets you down, eat broccoli soup and unlock the secrets to healthy aging. And Brock and roll.